Hello students, this is class 9 science, chapter 8. The name of the chapter is motion. Students, in this chapter we'll be discussing about the motion. So here are the brief overview of the lesson that we will be discussing throughout the chapter. So first we will discuss about the definitions, then after that type of motions, an equation of motions, graphical representation of motions. Motion and rest are the relative terms. About this topic we'll discuss first, then reference point, distance and displacement, speed and velocity. These are some of the basic terms and definitions that we'll be frequently using throughout this chapter. So first we'll be familiar with these terms. Then after that we will discuss about the type of motions. It's a uniform motion and non-uniform motion. Students, in this chapter we'll discuss about a type of motion called a rectilinear motion. That means the motion in a straight line. If a body moves in a straight line, we call such type of motion as a rectilinear motion. So we'll discuss about the uniform and non-uniform motion. Then after that, we will discuss about the equations of motions. Now that linear motions can be represented by certain mathematical equations. So we will discuss about those equations, the first equation, second equations and third equation. This equation V is equal to U plus AT is called a VT relation, which is also called a first equation of motion. S is equal to UT plus half AT square. This is PT relation, which means position time relation. This is also called second equation of motion. And V square minus U square is twice AS, which is PV relation, means position velocity relation, which is also called third equation of motion. Then after that, we'll discuss about the representation, the graphical representation of motions. We can represent graphically the motion described by a body. We have two types of a graph. That's PT graph, means position time graph, and VT graph, that's a velocity time graph. And we'll discuss about its importance. What is the importance? What is the significance of expressing the motions in graphical form? So there are two ways of representing linear motion or rectilinear motion. One is mathematical form. We'll discuss about the mathematical equations that describes the linear motion. And there's another way of expressing or describing the motion. That's what the graphical representations. Both have their own importance. We'll discuss about that importance. So let's start, student. First, we will discuss about the term motion and rest. So what is motion? When a body changes its position with respect to a reference point, the body is said to be in motion. Students, to understand the motion term, we must be familiar with reference point. Now, what is a reference point? Reference point means a fixed point with respect to which we measure something. Now, what is the meaning of this fixed point and what is the meaning of measuring something with respect to reference point? If I ask someone, where is your home? That person may say, my home is nearby this. That person will be using like school or police station or post office or bank or hospital or school as a reference point. So the person may say my home is just nearby school, or my home is on the opposite side of a post office. So when someone is describing his or her home or location, that person uses the reference like bank or post office or hospitals or a school or a police stations. So this fixed landmark which someone uses to describe their location, that fixed landmark is called a reference point. So this is what we mean with a reference point. So when we are measuring something, measuring position of an object, we use that reference point, that landmark, that is called a reference point. So motion means when a body changes its position with respect to a reference point, the body is said to be in motion. Say suppose, imagine a situation where a car is in front of a bank. After some time, you saw that car away from the bank. So you can say the car has moved. How do you know this? You'll give the reason after you'll give the reason. Just a while ago, the car was in front of the bank. Now the car is away from the bank. That means to describe the position of the car, you used the bank as a reference point. Now the car is away from the bank. That means we can say the car has moved. So when something, a body, changes its position with respect to a reference point, we say the body is in motion. So that's what we mean by motion. Student, I hope you understood what is motion means. Now next comes rest. When a body do not change its position, the body is said to be at rest. Take the example of the same car which was in front of the bank. You saw that car at, say, suppose 9 a.m. in the morning. And when you are seeing that car after 1 hour, say at 10 a.m., you see the car exactly at the same point where you saw that car just 1 hour ago. It means the car didn't move. The car was not in motion because the car didn't change its positions. How do you know the car didn't change its position? Because the car was in front of the bank. After 1 hour also the car is in front of the bank. So that's why we can say the car didn't change the position. So the car was at rest. Now students, pay attention to this line. This is very, very important. Rest and motions are relative terms. When I say rest and motions are relative terms, what does it mean? In nature, nothing is in permanent motion. Nothing is at permanent rest. Now suppose we are sitting inside a classroom. We and our friends sitting on the bench, we are at rest. But someone who is on the moon, say suppose, if that person see us, that person will see us moving. So when we are inside the class and when we see each other, we are not moving. But someone who is outside the earth, if that person sees us, for that person we are moving. So at the same point we are in motion and at the same time we are at rest. So we cannot say something at a permanent rest and something in permanent motion. That's why we say rest and motion are relative terms. So that's what we mean by rest and motion being relative terms. So nothing is in permanent motion and nothing is in permanent rest. One more example we can take. Suppose you are inside a moving car with your friends. When you see your friend is at rest. But someone who is outside the car, if that person sees you, both of you, for that person you are in motion. So from this example we can understand that nothing is at permanent rest and nothing is in permanent motion. So that's why we say rest and motion are relative terms. So reference points. About the reference point we have already discussed, students. Reference point is the fixed landmark that we use to describe the location of something. That fixed landmark is called a reference point. Student, let's move on to another topic. What is it? Physical quantity. Students, in physics, we measure the things. We measure the quantities. What is those quantities called? Measurable quantities are called physical quantities. Measurable quantities with the help of which the law of physics and the nature can be described. Those measurable quantities are called physical quantities. Like length is measurable, time is measurable, distance is measurable, speed is measurable, mass is measurable, force is measurable, current measurable. Like that, many quantities are measurable. So all those measurable quantities that can describe, that are used to describe the physics laws, those quantities, those measurable quantities are called physical quantities. Students, in physics, we classify physical quantities into two types. The first type is called a scalar quantity and the second type of physical quantity is called a vector quantity. Now what is this scalar and vector quantities? Those physical quantities where we are concerned with, we are interested with only its amount. We are not interested in its direction. Such physical quantities are called scalar quantities. Example, you see distance and temperature. I think temperature is one very good example that will make this point very clear. Say suppose, if I ask what is the temperature of a human body, the temperature of your normal human body temperature is around 37 degrees Celsius. We say only 37 degrees Celsius, students. We never say 37 degrees Celsius north or 37 degrees Celsius south. We don't say that. So that means while measuring the temperature, we are interested in measuring its magnitude, its value. Magnitude means value, amount. We are not interested in its direction. So that's what we mean by scalar quantities. Those physical quantities where we are interested in its magnitude only and not direction, such physical quantities are called scalar. Now vector quantities. What is vector quantities? those quantities where we are interested in both in its magnitude and direction. Such quantities are called vector quantities. Now example C, velocity. Velocity, we'll discuss after a short while what is velocity. Velocity, for the time being, you just understand it's a speed in a particular direction. Suppose the two aeroplanes in air, they're heading towards each other. If the pilots flying the aeroplane, if they are not aware of their direction and their speed, the two planes may collide. So that's why the two pilots must be aware of their direction. You might have heard the pilots talking about their directions, talking about their height, at what height the plane is flying, at what speed the plane is flying, which directions they are heading. So the pilots, they are talking about the velocity, means they are interested in their speed also, at what speed they are flying and at what height, at what angle, which direction they are heading. So they are interested in magnitude, the amount of speed, and in what direction they are moving. That means they are talking about vector quantities, velocity. So that's how we classify physical quantities in physics, scalar quantity and vector quantities. So scalar, we are interested in its magnitude, only amount, we are not interested in directions. But in vector quantity, we are interested in its magnitude, amount, as well as the directions. So that's how we classify the physical quantities as scalar and vector. So I hope, student, you understood the difference between this scalar quantities and vector quantities. Now let's move on to our next definition, that is distance and displacement, speed and velocity. So distance, what is distance? Distance is the length of the path actually covered by the body. And what is displacement? The shortest distance joining the initial and final position. Now students, let's understand, taking one example. Say suppose these are the 2 points. Let's say A and this is B. Now if I want to move from point A to B, I have infinite number of a path to go from A to B. I can take this route. I can move this way. I can move this way. I can take this route as well. I can walk along this path to reach the point B. So we have infinite number of paths to move from point A to B. Let's say suppose I walked along this path. I take this path to reach this point. So the length of the path walked by me is called distance. So this is my distance. Say suppose someone takes this path, walks along this path to reach point B. So what is his distance? The length of this path which is taken by that person will be his distance. So that's for the distance. What about the displacement? The displacement means the shortest distance joining initial and final position. Now suppose we have this path, this path, this path, and one more path is there, which is a straight line joining A and B. This is the shortest path of all these paths. So this shortest path which joins point A and B is called a displacement. Now when a person moves from point A to B taking any of the path, we can state two important quantities. We can associate two important quantities with that person's movement. What is it? One is distance, another one is displacement. Say suppose if the person walks along this path, so we can associate distance and displacement with the movement of that person. The length of the path walked by this person to reach point B will be his distance. But the change in position, the shortest distance will be his displacement. Now say suppose person 1 takes this route to reach point B, and say suppose person 2 takes this route to reach point B. So of course the length of this path is more than the length of this path. So person 1 have distance more than the distance covered by person 2. But both this person will have the same displacement because they simply moved from point A to B. The change in position is same. So that's why displacement will be same in both the cases. So that's what we mean by distance and displacement, student. I hope you understood what is the difference between distance and displacement. Now distance is always positive quantity. Displacement can be positive, negative, and zero. Now what is the meaning of distance being always positive? And displacement is a positive, negative, zero. Here positive, negative, and zero. Positive and negative simply indicates the direction. In maths, we know number line. This is the origin. Towards the right side we consider positive, and towards the left side we consider the negative. So upward we consider positive and downward negative. So when I say positive, it means the displacement is towards the right side. When I say negative, the displacement is towards the left side. And zero displacement. We'll discuss about this zero displacement after a short while, students. Distance will always be positive. Distance can never be negative. And distance can never be zero. But displacement, you may have a positive displacement, you have a negative displacement, or a zero displacement. Let's say, suppose, coming back to the same example, if a person walks along this path to reach point B and returns along this path to reach this point B. That means the person has taken this path to reach B and taken this path to reach point A. That means the person has covered certain distance. But because he started from point A and finally ended at point A, so change in position is 0. That's why this person's displacement will be 0. Now take one more example. Say suppose we have a circular field. Let's say suppose a person starts from point A, makes one complete round of the circular path and reaches point A. That means this person has covered a distance equal to the circumference of this circular path. But because the person has started from point A and has reached point A, so change in position is 0. That's why his displacement will be 0. So this is what the distance and displacement being positive and being negative and positive means. Students, distance is a scalar quantity. You know what is the scalar quantity now? We are concerned with their magnitude only. We are not interested in its direction. But displacement is a vector quantity. Displacement is a vector quantity because we are interested in its direction as well. Distance is measured in a meter and displacement also measured in meter. So SI unit of measurement of distance and displacement are same. It's a meter. So that's all about this distance and displacement. Let's take one more example to understand this displacement, distance and displacement. Let's say suppose I have a semicircular path. This is semicircular path. The diameter of the semicircular path is, let's say, suppose 7 meter. A person starts from one end of the diameter, walks along the semicircular path and reaches the other end of the diameter and stops there, say point B. Now if I ask you, what is the distance covered by this person? So distance will be the length of the path actually walked by the person. So this is the path along which the person walked. So this is what? It's a semicircle. So length of the semicircle is, you know students, it's a pi r. So 22 by 7 into radius is 7 by 2. So will give us 11. So we can say 11 meter is his distance. Now if I ask you what is his displacement? His displacement will be 7 meters displacement because he started from point A and ended at point B. So the shortest distance joining point A and B length is 7 meters. So his displacement will be 7 meters. So in displacement we are not interested in path. Whichever path a person may follow, displacement will be same if the initial point, starting point and final point is same. So this is distance and displacement, students. Next comes speed and velocity. Speed and velocity. Student, we know what is a speed. Speed is the distance covered by the body in unit time. When I say unit time, it means 1 second or 1 minute or 1 hour. A body covered distance. The distance covered by the body in unit time, the distance covered by the body in 1 second or 1 minute or 1 hour is called a speed. When I say speed is 50 km per hour. So all of us, we know about this kilometer per hour. 50 km per hour, that's the speed. When I say 50 km per hour, it means the body has covered a distance of 50 km in 1 hour. So how much distance is covered by a body in 1 hour or 1 minute or 1 second? That distance covered is called speed. What is velocity? The displacement of the body per unit time. In unit time means in 1 second how much the body has displaced. The body has changed position. So how much position is changed by the body in unit time in 1 minute or 1 second or 1 hour? The change in position is called a displacement. Now coming back to the same example. Say suppose this is 5 and this is 5. Let's say suppose this is 10. So if the person walks along this path, how much is the distance covered? 5 plus 5 plus 5, it's a 15. So distance covered is 15. What is his displacement? His displacement is 10. The shortest distance joining initial and final point is 10. So displacement is 10, distance is 15. Say suppose it took him 1 second to move 15 meter and it took 1 second to change the position. So in 1 second, how much is the distance covered? 15. So speed is 15 meter per second. In 1 second, the distance covered is 15 meter. So it means the speed of this body is 15 meter per second. Displacement. Velocity. Displacement is 10. It took this body to change its position 1 second. In 1 second, the position changes 10 meter. So we can say 10 meter per second is its velocity. So distance covered, the length of the path actually worked in unit time is the speed. And change in position in unit time is the velocity. So speed is a scalar quantity, students. Scalar, we are interested in its magnitude, amount only, and not direction. That's a scalar quantity. Vector quantities are those quantities where we are interested in both magnitude and directions. So velocity is a vector quantity. Student, speed is always positive. Velocity can be positive, negative, or zero. Units. In which unit do we measure speed and velocity? We measure speed and velocity in both the same units. It's a meter per second, meter per second, meter per second. Students, you can write meter per second as a ms minus 1, or you can also write m/s. Any one of the two can be used to indicate the unit of speed or the velocity. Either write this one or this one. You cannot write like this, m/-1. This is incorrect.